Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 110th of physics, and today we are going to start the new topic, and that is current electricity. From the light bulb to television, from voltmeter to computer, most of our modern equipment depends on electricity to function. We have come to depend so much on electricity that it is difficult to imagine what life would be like without it. Since we depend so much on electricity, it is important that we know what it is so that we can make the best use of it. We will be discussing electrical quantities such as current, resistance, EMF, and potential difference. Take careful note of the meaning of these quantities. We will also discuss how to measure some of these quantities. We will end the unit with the study of electric circuits. This is where we will apply our electrical knowledge to the understanding of series and parallel circuits. So let us begin with the topic named static charge and electric current. In the previous unit, we learned that electrical insulators and conductors can be charged by friction and induction. For an isolated charge conductor, the charges on its surface do not move. In other words, they are static charges. However, if we provide a conducting path, the charges will flow. When this happens, we say an electrical current is produced. So, in nutshell, we can say that charges at rest is called electrostatic, and charges at motion is called current electricity. To show that moving charges constitute an electric current, we can set up the following experiment as shown in the figure. At the start of the experiment, the two plug keys K1 and K2 are uh, taken out, and the two metal plates A and B are uncharged. First, plug in K1 to provide a continuous conducting path called a circuit, linking the extra high tension power supply to the two metal plates A and B. These are the two metal plates A and B, and this is extra high tension supply. So when we connect K1, it will provide this path. Going in this way, it will provide a path, and the circuit will be completed. Remember that K2 is not plugged in this particular case. Only K1 is plugged in, and only one path for the flow of charges from positive to negative in this case. So far, we are dealing with the conventional current, which is due to the flow of positive charges. But nowadays, we are not using that conventional current, we are using non conventional current, and that is due to the flow of electrons. Switch on the power supply to charge up the two metal plates positively and negatively by an equal amount. Now remove K1 and plug in K2 to provide continuous conducting path linking the charged metal plates to sensitive center 0 galvanometer, which is this one. Remember that a galvanometer is a device which is used to detect the current. It is used for detecting the current and not for measuring the current. For measurement of current, we use another device called a meter. When the current is passing through this galvanometer, the pointer in the galvanometer is seen to deflect momentarily to one side and then quickly return to zero. The galvanometer's deflection shows that an electric current is present. The current is caused by the flow of electrons from the negatively charged plate B through the galvanometer and then to the positively charged plate A. At plate A, the positive charges are neutralized by the incoming negatively charged electrons. This explains why there is only a transient or brief current detected by the galvanometer due to the discharge of the two metal plates. When this current is going in this way, this is not conventional current as I talked to you at the beginning. So it will pass this galvanometer and it will move towards the positive charge. When they reach this positive charge, so the positive charge will be neutralized by the incoming uh, negative charges, and they will neutralize and cancel the effect of each other. So the charge on the plate A will be vanished, and that is why this galvanometer is showing a small deflection of needle momentarily, because after the neutralization there will be no current flow and the galvanometer will not show any deflection in this particular scenario. Now let us talk about the conventional current. We are saying that conventionally the direction of the electric current is to be the flow of positive charge, which is not the case in only in older days we were using this concept, but we are not changing it because literature of conventional current is available in huge amount. Conventionally, the direction of the electric current is taken to be the flow of positive charge. The arrow drawn on the wire as shown in the figure represent the conventional current direction during discharging of plate both the plates A and B. As mentioned earlier, the current detected by the galvanometer is actually due to the negatively charged electrons moving from plate B to plate A. This electron flow is in the opposite direction to that of the conventional current. Remember that conventional current is due to the flow of positively charged plates. But nowadays we are taking the opposite of it, and that is the flow of negative charge is called current. Now let us turn our focus to the next and very important topic, and that is the measurement of current. As I told you earlier that current can be detected by galvanometer, but current can be measured by the instrument called a meter. But let us first discuss that what is current. An electric current I is a measure of the rate of flow of electric charge Q through a given cross section of a conductor. In symbols, we can write this I is equal to Q divided by T, where I is equal to current, Q is equal to charge, and T is equal to time. Now let us talk about the unit of the current. Just as we have learned in the previous unit that the SI unit for the charge is the coulomb, which is denoted by capital C. The SI unit of the current is ampere, denoted by capital letter A. Therefore, we can say that a current of 1 ampere is a flow of charge at the rate of 1 coulomb per second. Keep in mind that this is not the definition of ampere. We will shortly define the ampere. A larger current of say 10 ampere is a very large current will mean that 10 coulombs of charge flows past a given cross section of a conductor in 1 second. The size of the current such as 1 ampere or 10 ampere can be measured by means of an electrical device called ammeter as shown in the figure. This is the ammeter. So this is used for the measurement of the current. To use the ammeter in measurement of an electrical current, this is very important sentence. The ammeter must be connected in series to the circuit. We will talk about the series and parallel circuits at the end of this chapter. But for the time being, remember that if one end is connected to the other end and the other end is connected to the third one, like in this way, head to head, then it is called series circuit. So keep in mind that ammeter will always be connected in the circuit for the measurement of current in series. We will never attach it in parallel circuit. In this way, the current flow into the ammeter by the positive or red terminal is shown and labeled in the diagram terminal and leaves by the negative or black terminal. This is illustrated in the figure. Note that in a series circuit there is only one single conducting path or loop. This is very important because if you are starting from here, so there is only one conducting path or loop. So this is called a series circuit. But if there is a division of path, one is going in this way and one is going in this way, and there are loads connected to these wires which is shown in this, then this is called parallel circuit. If there are two paths, one is this one and one is this one, then this is called parallel. But if there is only one path for the conduction of current, then we are saying that all the devices are connected in series. Ladies and gentlemen, tomorrow we will do the numerical questions on this, and we will also talk about the electric symbols used in circuits and the current electricity. So those are very important topics. Don't miss it. Stick to this channel. Subscribe it if you haven't subscribed it. Thank you very much for your time. Allah Hafiz.